Hello everyone, welcome to the fifth in our series of Marine Tech webinars. My name is Chelsea and I work for Plymouth City Council and I will be your host for this event. Just a reminder that during this webinar you will only be able to hear myself and our presenter speak. We will not be able to see or hear any delegates. After the presentation we will be holding a Q&A session. Please use the Q&A chat bar to ask any questions throughout the presentation. If you see any questions you would like to hear the answer to also, you can give it a like and this will send that question to the top of the pile. Just a reminder, this webinar is being recorded with the intention to be available to others on demand after. Enjoy, and I will now hand you over to Professor Icarus Allen, Chief Executive of Plymouth Marine Laboratories and PML Applications.
Okay, thank you, Chelsea. Good morning and welcome to the seminar. My name is Icarus Allen. I'm Chief Executive of the Plymouth Marine Laboratory and PML Applications. I've been in post now for about 9 months, so I'm relatively new in the job, although I've worked for PML for nearly 30 years. What I'm going to do this morning is give you a little bit of a run through of some of the things we do at PML and PML Applications, and a little bit of, I guess, about the sort of philosophy and ethos that underpins us. Our strapline is at the top there, which is research excellence supporting a sustainable ocean, and that I think exists to try and convey what we're trying to do. So firstly, PML is a registered charity, so we're governed by a board of trustees, but perhaps more importantly, our vision is a healthy and sustainable ocean through the delivery of impactful, cutting-edge environmental and social science, enhancing PML's position as a world leader in the field. So PML has been around in various guises in Plymouth for about 40 years, and as I said, we've been a charity since 2002. I guess, so why do we exist? And I think it really comes back to the fundamental challenges that the Earth and the oceans are facing. You know, there's firstly global environmental change, and secondly, the role of the ocean in providing resources to support the 9 billion people on the planet. So we see our role as being able to, how do we understand how ocean processes work? How do we best make use of resources in a sustainable manner? How do we support people? How do we mitigate risk? So the ocean itself, I mean, it's 99% the living space on the Earth. Something like half the planet's population depend on the ocean as a primary source of food. It has a huge role in regulating climate and affects the weather. It's a major source of oxygen on the planet. So 50% of all the oxygen, we believe, comes from mostly from phytoplankton in the oceans. It's home to 80% of the Earth's living organisations, and it's the major trade routes in the world. So, stealing the quote at the bottom from the UN Secretary General, but the oceans and the seas are inextricably linked to all of us, the health of the planet and to every individual. So PML, we've been around for 40 years, and we've been doing pioneering research on the global ocean and its ecosystems for those 40 years, and over the last 20 years we've also been looking at the benefit for society's health and prosperity. We exist as an independent and impartial provider of policy relevant scientific research and advice. Our research has been consistently recognised internationally for over 40 years, and we do very highly impactful science, contributing to all sorts of activities, for example, the National Ecosystem Assessment. And we have a very strong interdisciplinary approach to research. So we're looking at addressing complex challenges. We're looking at bringing together multiple disciplines from physics and chemistry to biology and ecology through to social science and psychology. We run global comprehensive observing systems locally and globally, locally through the Western Channel Observatory, globally through using satellites. We partner with over 600 organisations. We work in 60 plus countries, and we're recognised as the world leader in marine ecology, in coastal modelling, in remote sensing. So really the motivation to do this is to try and understand how the oceans work, how they impact on the people. You know, we're looking at a whole variety of issues. We're looking at global change. We're looking at how that impacts on ecology, how that impacts on the supply of fish. In order to underpin this, we're looking at marine observations. We're involved in working out how we live with global change. We're working with the renewables industry. We're looking at environment and human health, carbon capture and storage, the impacts of pollutants, including microplastics and carbon dioxide. And what we bring to the table is a team of world-class researchers. We have state-of-the-art laboratory facilities. About 18 months ago, we went through a £5.5 million refurbishment so that the building now has had all its laboratories refurbished, and we're in a very strong position to go forward for the next 20 years or so. We undertake long-term in situ monitoring. We take a global view with satellites, and we have a huge amount of international partnerships. You know, our approach is very much around looking at challenges and questions, and perhaps one of the uniquenesses of our approach is in a small organisation is we combine a great strength in observations with experimentation and numerical modelling, and it's only by bringing these things together that you really get a deeper understanding of the complex and dynamic marine ecosystem. And this is one of the things that allows us to provide evidence-based research. Okay, some of the facilities we have, again, long-term monitoring. We have a high-performance computing. We have a wide range of controllable experimental environments. State-of-the-art microscopy, one of the fastest atomic force microscopes in the world. Social and economic research. And we're doing research at a variety of scales, from local to global. We're leading major research programs. We're working to understand the effects of climate change in the Arctic and global consequences. We're leading international activities and cruises. We're doing innovative research in the UK and overseas, particularly in the realm of ODA work. And we've led some award-winning science, particularly on microplastics research and Earth observation, which have won major impact awards. So some of the things we're looking at. You know, the ocean is a complicated thing. It's facing multiple threats, and one of the great challenges is really understanding how these multiple threats interact with each other and what the consequences will be. You know, there's a number of areas where we're working. We're looking very much at climate change. We're doing this through monitoring and long-term time series. We're doing this through numerical modelling, particularly working with the Met Office on the Earth System Model. We're also engaging at a policy level on ocean climate change and ocean acidification, and for many years we've been engaged in the COP process, and most recently at the COP in Madrid, the one that was postponed from Chile in November. And we've had a major influence in, particularly in bringing ocean climate change up the agenda at international government level. We've been working particularly with the teams at the University of Plymouth and also the University of Exeter on marine plastics. We did some of the original work on the uptake of microplastic beads by zooplankton, and you may have seen some of the footage on Blue Planet. And more recently, we've developed a novel way of looking for plastic debris from satellites, which was published recently. Another area we're looking at now is the impact of light pollution, particularly on seabed, you know, on ecology and animal behaviour. And in shallow coastal areas, there's been an interesting change in that the street lighting has moved to LED from the old sodium lamps over the last few years. The old sodium lamps produce red light, which is absorbed by water. The LED lights tend to produce a lot more blue light, which means the water penetrates much deeper into the water column. So now we're disturbing the day-night diurnal cycles of organisms. So we're currently about to undertake a large-scale experiment to try and quantify the consequences of that. It's again trying to understand the complexity of the system. And underpinning all this is the importance of observations and long-term time series. Now, out in the Channel, we have one of the longest time series in the world. The Western Channel Observatory, certainly the E1 station, which was run originally by the NBA and now co-run with the NBA, has been there for nearly over 100 years. And this provides a baseline for seeing how the system is changing. And here we're looking at physical oceanography, we're looking at phytoplankton, we're looking at seabed fauna, and we're able to understand the changes that happen both seasonally and annually. And we're able to interrogate this to try and unravel the impact of climate and also the impact of other stresses and pollutants on marine ecosystems. And this provides an evidence base for guiding the development of, for example, marine protected areas, the development of marine policy to protect the environment generally. The marine environment, of course, provides a lot of hidden benefits, things we don't directly perceive. A very obvious one is the notion of blue carbon, and there are a variety of ecosystems that in and around coastal seas, most notably salt marshes and mangroves in the tropical areas, and large kelp beds, which play an important role in sequestrating carbon from the atmosphere. And the management and improvement of these is potentially a climate change mitigation strategy. We've been looking at the properties of seaweed and whether or not you can extract large-scale edible oils from seaweeds as an alternative to terrestrial oil production. And finally, there's the whole issue of the ecosystem and their value. I mean, we're sort of quite familiar with the tangible benefits of the ecosystem, for example, from fisheries, or we can quantify the value of transport or the energy produced from the marine system. But there's also considering the intangible values. It's what's the aesthetic and cultural values of the system, and what and how does that impact on other sectors, for example, tourism. We have a very strong portfolio of training and capacity building. We have a long history of building partnerships. We've been training PhD students for 40 years. We're currently working with a number of international organisations. We're putting students from developing nations on cruises, on our annual cruises of the Atlantic. We're working and training people in Southeast Asia. So there's a whole variety of activities. And more recently, we've been engaging with apprentices, and PML now has a strong apprenticeship programme which is developing the next generation of marine environmental science technicians in the laboratory. And we're always open to innovation. I mean, we're looking for new challenges, we're looking for new approaches. I mean, there are two things that are very high on the agenda at the moment. The first one is artificial intelligence. There's a couple of examples here. Firstly, the use of artificial intelligence to improve the quality of satellite pictures, which are notoriously influenced by cloud, and artificial intelligence provides a way of removing some of the cloud. And also, secondly, how we can go from the traditional way of looking at identifying, say, phytoplankton and zooplankton from microscopes to automating this. And we've been using artificial intelligence to attach to a device called FlowCam, which takes pictures of the organisms, and then you can classify them using artificial intelligence. And this is now getting up to a 97–98% success rate compared with manual detection. And underpinning all this, we've just had an investment of £1 million in what we call the Maggio GPU cluster, which has come from the National Environment Research Council, and this will allow us to massively increase our capacity to undertake artificial intelligence research. This is currently goes live next week. Finally, there's the smart sound. So this is building on our long-standing observational tradition in and around Plymouth, but now building around that, putting in the infrastructure of buoys and autonomous vehicles and communications to provide an environment for not just marine research, but also innovation, the testing of vehicles, the testing of instruments, and a wider opportunity for not just research but also commercial innovation. So in summary, we deliver this through a number of science areas. So we're bringing together a variety of disciplines. Firstly, there's the socioeconomics. We have a group we call Sea and Society, and their core business is trying to understand the consequences of benefits and of the interactions between mankind, society and the marine environment. And the goal for that is really to try and improve outcomes and support sustainable ocean stewardship. We have a very large group based on satellite Earth observation. This is possibly the largest group undertaking this activity in Europe in the marine field, and really using satellite, not just satellites, but increasingly things like drones as well, to take aerial observations of the synoptic observations of the environment, and then we're looking at how we can apply these in a variety of things, from understanding physical and ecological processes to monitoring oil spills and monitoring illegal fishing activity, to detecting plastics in the ocean and harmful algal blooms. We have a long tradition of working in marine biogeochemistry, particularly in terms of quantifying the carbon and nitrogen cycles, and a very long history of marine ecology and biodiversity, which is underpinned by local sampling. And we have a long tradition of doing work looking at the stress responses of organisms, not just to pollutants, but also to things like temperature and carbon dioxide, and increasingly things like plastic. And finally, we have a very large numerical modelling group, and again, possibly the largest one in Europe, looking at marine ecosystem modelling and how we can bring all these things together in a dynamic computational framework to understand how they interact with each other and to make predictions for the future. Okay. Our work is highly cited, our work has far-reaching impact, and we've provided evidence to policy and industry. We contribute to the training of the next generation of scientists. And we work with all sorts of organisations that try and embrace sustainable practices. And increasingly, we're looking at how we can support the blue economy, both locally through working with things like the Marine Technology Business Cluster and in Oceansgate, using initiatives like the Smart Sound and looking at issues of in environmental data and environmental intelligence, and also globally we're also looking in terms of how we can support development of blue economy in developing nations. And as part of this, PML has a commercial trading subsidy, PML applications. So PML applications has existed alongside the charity since 2002. It sits there and offers commercial services in shipping, marine renewables, paint and performance coating, and also marine and satellite applications. And we have 4 core business areas: Ballast Water Centre, which is focused largely on the testing of ballast water systems for the cruise industry at the moment. Centre for Marine Biofouling and Corrosion, which is looking at the testing of biofouling and paint coatings for ships. And we have a number of test sites in and around Plymouth, and Buoy out in the Channel, and a test site in Mill Bay Docks. And we're also increasingly looking at in-hull cleaning. The Centre for Geospatial Applications. Now this feeds off the Earth Observation Group that sits within PML, and is really looking at the commercialisation of some of the research into business streams to provide data on a commercial basis. And a Centre for Environmental Solutions, which undertakes general environmental consultancy. So we're working in market sectors such as shipping, paint performance coating, oil and gas, marine energy. We're increasingly looking at how we can engage, for example, in the burgeoning offshore floating wind sector that we hope will develop in the southwest in the near future. And we see there's a number of our clients. So I'm going to call it quits there. Thank you very much for your time. I'm quite happy to ask any questions. So I look forward to interacting with you. Thank you.
Okay, thank you for that, Icarus. If anyone has any questions, please just type them in the Q&A bar here. There is a 30-second delay between us and you as a delegate, so I will give it a minute and see if any questions come through.
Oh. No, yes. It always seems quite strange talking into a void on these things. I do find it, I don't know how other people feel about it, but I do find it quite difficult when you can't see any kind of audience reaction.
Yeah, it is strange. Okay, looks like everyone's happy. No questions have come through as of yet, so I will close the webinar now. If you do have any follow-up questions, I think a question's just come through.
That's it. Okay.
Yep. Okay, so the first question is, can you describe/explain your working relationship with Plymouth University?
Okay. Well, firstly, we're independent from Plymouth University. We work with them collaboratively at a number of levels. We share PhD students, for example. We have a number of joint grants. We are working with the university and with the Marine Biological Association to develop the Plymouth Marine Research Partnership. So we're looking to bring together the marine research and innovation in Plymouth and provide a focal point for developing that, which would sit alongside the initiatives in Oceansgate. The very nature of marine research funding means that there's always an element of collaboration, there's always an element of competition, but I guess that's like most business relationships. And sometimes you just have to have sensible conversations about whether you're going to collaborate or compete. We're also working together with the university and the MBA through the Marine Business Technology Cluster and the Smart Sound and other local initiatives. So, we work together with them in a very constructive manner. Occasionally we compete with each other.
Okay, thanks for that. I'll just give it a minute to see if there's any follow-up questions from that. I don't think there is, so I will start to bring it to a close. If there are any follow-up questions that you would like to ask direct, you all have my contact details, so I can forward any other questions on to Icarus Direct. Thank you all for joining, and the next webinar we have in 2 weeks' time, and that is in fact with Plymouth University.
I hope someone's going to ask them the same question, see what answer they give.
Yeah, make sure they answer the same. Another question's just come through, so I'll publish that one and we can have a look at this one. So this question's come from Ellie. What opportunities are there to conduct postgraduate research projects with PML, and are there possibilities for careers after graduation? Okay,
well, we work in partnership. We have a number of PhD student partnerships we work with. There's a group called GW4+, which involves the University of Exeter and Bristol and Bath and Cardiff. And there's another grouping called ARES, which involves the University of East Anglia and the University of Plymouth and University of Essex. So that, and then we are involved. We also seek bilateral. We have some bilateral PhD studentships with the university. Where we advertise them on our website when they're available. The PhD advertising season is usually in the late autumn, so it's a good idea to have a look on our website. it's often highly competitive, but you know, that's perhaps how it should be. In terms of the opportunities after a PhD, well, somewhat uniquely, I think, you know, we did a survey of this about 18 months ago. And in the last 5 or 6 years, virtually everybody who completed a PhD while working at PML had gone into a research career, which is quite disproportionately high, because I think the average is, you know, the average numbers that do so is less. But I do think that's possibly some of the advantage of actually, you know, doing your PhD in a working laboratory rather than in a university environment. But okay, so there is work out there. There are jobs if you do a PhD. PhDs are available. As I said, the season for looking for them is coming up in the autumn. So keep an eye on the adverts.
Okay, that's great. So there's no more questions waiting for me to publish. So I will bring this to a close now. But as I said, any follow-up questions, please give me an email or a ring. Thank you for your time today, Icarus. Is there anything else from you?
No, just to say thank you very much for people for their time. I hope it's been useful, and hopefully might get to see some of you one day.
Okay, that's great. Thank you. And we will be publishing this webinar through our social media channels within the next day or two if you did want to go through any of the presentation again. Okay, thank you all. I will now bring this to a close.